Welcome to this video on DPLYR. DPLYR is a language of data manipulation which consists of various verbs like select, arrange, filter, mutate, summarize, and many more, which can be used to make simple or complicated data manipulation commands.
This video is about the filter command in DPLYR. We have already covered another video for the select command and the arrange command. So this is the third video in that section. We'll be using these two packages, the DPLYR package and the stringer package. And if you haven't got them installed, you can go and install them using these commands. Filter is the most important verb or command in DPLYR because most of our work is about filtering the data, and we'll be talking about filtering the data in a single field, multiple fields, and then a single criteria, and searching multiple criteria in multiple fields. So let's get started with the data. The data consists of these commands. You don't really have to follow them because you can go to the description of this video and you will find the link. And if I run this chunk, we can see our data. So our data consists of about 100 records, 100 rows. We have various admitting hospitals, the different names, the gender, and some diagnostic information, diagnostic 1, diagnostic 2, diagnostic 3, and diagnostic 7, etc. So with the data, we can run our first command. The first command is the most simple filter command. So we are saying we want to use the filter command, and we want to use our data, which is D, the data which we just created. And within that data, we just want to filter the admitting hospitals by the value hospital A. Notice that we have given the double equal to sign in this for filtering the data. So if I run these two commands, this is what we get. We have got all the hospital A rows. So this is one way of using the filter command, but when we're using the pipe symbols, we can use it differently. So in the first line, we said D is our data source, and then we pipe the output of that using this pipe symbol in DPLYR, and we are saying that we want to now filter whatever we got up there by admitting hospital equals A. So this is exactly the same. The only thing is that we have actually got rid of D, so you don't really have to specify your data there because you've already done that in the first line. So if I run this, notice that we haven't got anything back, and the reason is that we didn't specify the hospital in the proper capitalization. The hospital values are starting with capital H and with the capital A. So to get rid of this situation, we can do two things. One is that we can specify everything in the lowercase, and then also say that I want to filter it using the toLower command. So the system is going to, first of all, change the admitting hospital values to lowercase and then start comparing it with this value. So if I run this, you would see that we have now been able to find the values, even though your value, the criteria was different. So the capitalization was different, but it still was able to match it. And in the next example, what I've done is I've actually used the toLower command in both of the actual data field and your actual criteria. See how we have given the criteria in a bit funny way. So by mistake, I've capitalized P and I've capitalized A. But if I run it, we would still be able to match the data because the system is converting everything to lowercase first on both sides and then start comparing it. So obviously it's going to get a good match. Now let's start comparing numerical values. Numerical values can simply be compared by the symbols like greater than, equal to, or lower. So running our first example, age greater than 20, we got the data. And in the next example, I'm piping few commands together, and this is the power of DPLYR. You can simply keep on writing simple commands and then keep on piping the output to the next one and so on. In this case, we are saying these are data. You're piping it to the filter command saying age has to be greater than 20. That's fine. And then we are saying we want to arrange the output of these two commands into age in ascending orders. So if we haven't specified ascending, that means by default it's always ascending order. And then at the end we are saying we want to use a rename feature also. We want to rename the age years as age space in space years. And notice that these funny back quotes, you have to specify whenever you have a blank or a space in your data fields. So if I run it, you would see that we have the data out, and instead of age years, we have age in years. And this is in an ascending order. So starting from the low value, going to the high value, and all the values are greater than 20. Now there is something else going on in the data where we can use the AND, OR, and XOR commands or operations. These are the binary operations which we can use in our filtering. So I'm going to create a simple data set called DF just to explain the AND, OR, and XOR features. So if I run this, we have a simple data, few names, and the patients have either taken a blue dose or a green dose. And in some cases, patients have taken both the doses, the blue and the green dose. So keeping that in mind, let's see what our data does. So we are saying now we just want to filter patients where they've taken a blue dose and a green dose. And if I run it, I'll get the patients who have taken the blue and the green dose. And now see this symbol, this is called the OR symbol. So we are saying that we want to find the patients who have either taken a blue dose or a green dose. So you have the patients where they've taken a blue dose or a green dose or both. So either of the situation, if you get a 1 there, the filter is going to return the data to us. Now this is a new feature I'm introducing. It's called XOR or XOR. So see what happens in this one. Let me run it first and then we'll talk. In this case, it has only given us 3 rows. In the previous ones, we have 5 rows where they have patients who have taken a blue dose or a green dose or both the doses. In this case, it has only given us the conditions where the patients have taken exactly 1 dose. The blue doses and the green dose, if you get a value of 1, for example, this record for Harry, XOR didn't bring it back. So XOR is used when you just want to pick exactly 1 condition. So either this or that. And remember that XOR is only going to work on 2 conditions. It doesn't work on 3 conditions or 4 conditions. So XOR only works on 2 conditions at a time. So if you had a pink dose, the blue dose equals 1, green dose equals 1, and pink dose equal 1, then it's not going to work. It's only going to work on exactly 2 conditions and then XORing them. Okay, now going back to the next command in our previous data set which we created. So I'm using the same command which you might be familiar by now. By using the AND command, I'm saying I want to filter the hospital by hospital L and we want to pick the age greater than 20. So it's going to do exactly what we wanted, admitting hospitals L, and then age is greater than 20. That's fine. Now another variation of that, see how we said AND there? You can achieve the same result by giving a comma. So comma is also acting like an AND command. So both the conditions have to be true. So this has to be true and this has to be true. Hospital L and age is greater than 20. That's fine. But there's another way of representing this. You could actually start creating multiple lines. So in this case, I'm saying filter it first by admitting hospitals equal hospital L, and then whatever is the output of these two commands, now filter it by age greater than 20. And then you can keep on piping more commands into this as well. So that is also going to work as AND. So in fact, what I'm saying is this command and this command and this command is going to produce exactly the same results. So they are the different ways of running the AND command. So this is also an AND, this is also an AND, and this is also an AND. Now, similarly, we can run multiple ORs. Filter admitting hospitals equals hospital F with a pipe symbol, which is the OR, and then outcome equals died. So let's run it, and we're going to get two hospital. So we're going to get the hospital. Either the hospital has to be hospital F or the outcome has to be died. So you can see that we get two records from hospital F where the outcome is survived, because we said that we want either the condition hospital F or we want to see where the outcome equals died. So all the other hospitals are also picked up where the outcome was died. So these two conditions are being met. Now we're going into the exciting part of filter, where we can filter for multiple conditions. You don't really have to specify different lines for specifying different options. We can just provide all the criteria in a single line or a list, saying we just want to say admitting hospital is either in hospital A or in hospital B. And then we are making it a bit more complicated by saying, and then we want to OR it and say outcome has to be died. So let's see the outcome. So we would, there are two things happening there. We are saying outcome equals died, or the hospital has to be in A or B. So if you look at the conditions where the outcome is not died, let's say for this one, we have the hospital B, which was picked up because of this. And now this is an AND condition with multiple criteria there. Slightly different result, because we are saying the hospital has to be A and B and the outcome has to be died. So we are picking basically all the dead patients from hospital A and hospital B. Now coming back to the numeric filters again. In this case, we want to give multiple conditions. Age has to be greater than 10. Age has to be less than 15. So we are saying we want to pick all the patients who are above 10 and less than 15. So in fact, it's going to give us all the patients starting from age 11, 12, 13, 14. So this is what we had in our data set. So we got this. Now we can also modify it by saying we want to have the greater than or equal to 10 and less than equal to 15. That means it's going to have all the patients between this range if they exist. So we have patients starting from 10 to 14. Obviously 15th wasn't there, so didn't return 15. Now this is an example of multiple conditions there. So the age is filtered there, and then in the second line we said we just wanted the patients who died. So if I run this, we would get all the dead patients from these hospitals between the age 10 and 15. There's a different way of specifying the between. Instead of saying this, you can simply say this, saying the age years has to be between 10 and 15. That will also work. So this will also work in the same way. So you got exactly the same results by using this instead of. Now, bit more exciting things, filtering it by a pattern. So there are various ways to do that, to filter the patterns. I'm using the grepl command, which comes from the base R package. So what we are saying is that we want to filter the diagnostic 1 column and we want to find a pattern of 0, 0. So if I run it, we can see that it has picked up all the diagnostic 1 values where the values have a 0, 0 in there. So that's fine, but sometimes you want to restrict your search by using just the starting position. In this case, I want to say I want to search the diagnostic 1 column and I want to search a pattern where the value starts with A. So this symbol is telling us that we want to look for the value A just at the starting position. We can see that we have got tag 1 where it starts from A. Now, more exciting things. Picking up a value anywhere in those. Remember that we got 7 diagnostic columns. So how do we do our search if we want to search on all the columns? Do we have to repeat it like where diagnostic 1 equals this, diagnostic 2 equals this, etc.? Or we can simply say filter at any variables which start with the word DIAG, which in fact means this, and in fact all of them, because they start with DIAG. And then we say we want to filter those variables, or the variables which were picked by using this command, where the value of those is G05. So notice the syntax. Notice this dot there. And we are filtering the value G05. So if I run this, we would only pick the values where there is a G05 in any of those diagnostic columns, the 7 of those diagnostic columns. So in fact, there's only one G05 value there. It has given us this. But if it happened to have a G05 somewhere there, it would have picked up that as well. Okay, now we are saying that we want to give multiple criteria. In the previous one, we just had one criteria. In this case, we want to give a multiple criteria, saying that we pick up all the variables where they start with the word diag, and then we want to filter them whether the value is G05 or this. In this case, it has picked up all the diag columns and then filtered them for the value G05, happens to be there, or Y71. So in this case, see that it's not G05, but it has the value Y71 in a different diagnostic column. So in fact, this is what this command really means. Now, this is using all the diagnostic columns. And in this case, we want to search for a pattern. So I'm using a different way of searching. I remember that we used grepl in the previous example somewhere. Remember we used grepl there for pattern matching, but in this case, we are going to use this detect from the stringer package. So we are saying that all the variables which start with diagnostic or the DIAG, we want to search for the pattern 05. So this is in fact searching multiple columns at the same time and searching for a pattern. So wherever we have 05 within the diagnostic columns, it has given us. So for example, we have a 05 there, we have a 05 there. So obviously we have a 05 there as well as 5 there. So all that diagnostic columns have been searched for the pattern 05. And then we can also use percentage like column as well, but we use a different package called data.table. So once we call that, I'm able to use the like feature. So like is nothing but a different way of using string. So I find this a bit more intuitive because it's simple. You don't really have to call this complicated thing. All you have to say is just like and then give the pattern. If I run this, we get exactly the same result, picking up all the diagnostic columns where the value or the pattern matches 0, 5. So for example, 0, 5, 0, 5, and so on. So this is all we have in this video. And I hope you found this information useful and practical. The filter is the most important verb I find within the DPLYR package. And once you master that, you can do any data manipulation quite easily. Thank you very much for watching it, and I'll see you in the next one.